So the last type of problems that you're going to be responsible for this next test are absolute value inequalities. So this first example, the absolute value of W is greater than 4. What an absolute value is a distance. So in this example, it's saying that W, whatever W is, it's going to be more than, greater than, greater than 4 units away from 0. So if I look at my number line, here's 0, and here's 1, 2, 3, 4 positive, and here's 1, 2, 3, 4 negative. What this absolute value means is whatever W is, it has to be more than 4 units away from 0. So it either has to be below -4 or it has to be above +4. Anything in those two intervals will be greater than 4 units away from 0. So to write that in interval format, from -infinity to -4, and I could use a union, and then from 4 to infinity. So anything between -4 and infinity, -infinity and -4, and 4 and +infinity. If I pick a number out of one of those intervals and put it back into the absolute value, I'm going to get greater than 4. So if I pick -5, so let's say W is -5. When I take the absolute value of it, it's equal to 5. And 5 is greater than 4. So any number in this interval all the way to -infinity, after I take the absolute value of it, is going to be greater than 4. Anything in this interval all the way to +infinity, if I take the absolute value of it, is going to be greater than 4. Anything in the interval between here, say this is -2. If I take the absolute value of -2, I get +2, and that is not greater than 4. So that's not part of the solution set. So here it is graphically, and here it is in interval format, the solution. What about over here? This one says that whatever W is, it's less than or equal to 2 units away from 0. So if I want it to be less than 2 units away, then it's going to be between the two. So anything between -2 and +2, if I put it back into that inequality, is going to be less than or equal to 2. So let's pick -1. If -1 is in the absolute value, well, the absolute value of -1 is 1, and that is less than or equal to 2. So in this case, our solution set, and since this is equal right here, I'm going to make a square bracket. From -2 to 2 is our solution set. So here it is graphically on a number line, and here it is in interval format. So depending on what it asks, if it asks you to show the number line, this is what you'd look like with brackets. It might have it with closed holes on the endpoints instead of a square bracket. That means the same thing. Okay, so let's look at the next one. The next one says 4 times the absolute value of 8 is greater than 28. Well, earlier when we were doing the inequalities, we decided we needed to get, or the absolute values, we want to get the absolute value by itself first. So let's divide both sides by 4. So now I have the absolute value of X is greater than 7. So whatever x is, it's got to be greater than 7 units away from 0. So it's either going to be, that's terrible, from negative infinity to negative 7, or from 7 to positive infinity. Anything in those two intervals will satisfy the original inequality. So if I have a negative 10, I put it in my original inequality. I put it 4 times the absolute value of negative 10 is greater than 28. So divide both sides by 4, and I got the absolute value of 10 is 10, and that is greater than 28 divided by 4, which is 7. So it checks. So here's my answer in interval format. Here's my answer in graphical format. I come over here, the first thing I need to do is get that absolute value sign by itself on one side of the equal sign or the inequality by adding 23 to both sides. So the absolute value of x is greater than, that doesn't change, 23 minus 9 must be 14. So now that says whatever x is, it's greater than 14 units away. So if you need to draw your number line, it's going to be open parens because it's not including the end point. 14, 14, negative. So it's going to be anything less than negative 14, anything greater than positive 14. So from negative infinity to negative 14, and or 14 to infinity. So anything in either one of these intervals, if I put it back into the original equation, say negative 16 is in this interval. If I put it back in the equation, negative 16 absolute value is 16 minus 23 is what? Negative 7. And negative 7 is greater than negative 9. I'm just checking. So interval format looks like this. Graphical format looks like this. And the set builder notation would be x is less than negative 14 and x is greater than positive 14. So that's a different way to write it. And up here, x is less than 7 or x is less than negative 7 and x is greater than positive 7. So that's another way to write it. So 3 different ways to write the same answer. Okay, so let's try this one. So this says saying whatever y minus 2 is, it's less than 6 units away from 0. So the easiest thing to do is, since it's less than, I'm going to make a compound inequality. So y minus 2 in the middle, I know that it's going to be between negative 6 and positive 6. So now I got rid of my absolute value sign, and I have a compound inequality, and I'm going to solve for x, or y, sorry. Negative 4 is less than y is less than 8. Anything in this interval, and if I write it in interval format, negative 4 to 8, anything in this interval, I could put 0. 0 minus 2 is an absolute value, is the absolute value of negative 2, which is 2, and that in fact is less than 6. So this is my solution set. If you wanted to write it on a number line, here's negative 4, here's 8, it's everything between. Same thing over here, whatever y minus 5 is, it's less than 2 units away from 0. So I'm going to put y minus 5 in the middle. And I know that y minus 5 is less than 2. And I know that it's between -2 and 2. So add 5. This one's just like the other one. Add 5. So 3 is less than y is less than 7. And put it in interval from 3 to 7. Anything between 3 and 7, and I'm not including the endpoints because of a value when I plug it back in will give me a value that's less than 2 after I take the absolute value. So what if I put a 4? If I know 4 is in my solution set, so the absolute value of 4 minus 5 is the absolute value of -1, but that's just 1, and 1 is less than 2. So that just shows that that particular number that's in the solution set does solve the equation or the inequality. Now this one's a little bit trickier because now I want the distance of whatever V is, I want the distance to be greater than 12. So that means that I'm going to draw a number line first. Whatever 4V plus 4 is, I want it to be greater than 12 units away. So I need, if this is 12, and -12, anything over here below -12 is also going to give me more than 12 units away. So I have to make 2 inequalities. Instead of a compound inequality, I need to make 2 inequalities. So on this one, I'm going to have 4V plus 4 is less than or equal to -12. And 4V plus 4 must be greater than or equal to +12 because I need it to be in these tails, not between. If it was less than, between, but it's greater than, so it has to be out here or out here. So 4V minus plus 4 is less than or equal to -12. So subtract 4, 4V minus 4V is less than or equal to -16. So 4V has to be less than or equal to, oops, what am I doing here? V has to be less than or equal to -4. That's part of the solution set. Now the same thing here, -4. So 4V has to be greater than or equal to 8. So V has to be greater than or equal to 8 divided by 4. So the number line is going to be a little bit different for my solution set. V has to be greater than or equal to 2. Oops. I don't want it quite that small. So V has to be greater than or equal to 2. So it's everything here. Or less than or equal to -4. So everything to the left of -4. So here is my set builder notation. Here's my number line interval notation. I'm going to have to rewrite it as, I'll come over here. I might run out of room. From -infinity to -4. In order for this absolute value to be greater than or equal to 12, my V has to be between -infinity and -4 or from 2 to infinity. So there's interval notation, there's graphical, there's set builder notation. They all mean the same thing. So over here, if it's greater than, I need 2 inequalities. So -12 minus 16y is less than -18 because I want it to be further than 18 units away. And -12 minus 6y has to be greater than +18. So let's go ahead and add 12 to both sides. Minus 6y is less than negative 6. Now here's where you have to be careful. If I divide both sides by a negative or multiply both sides by negative, I have to reverse the sign. So instead of being less than, now it has to be greater than. So y has to be greater than positive 1. That's what I got there. And then over here, if I add 12 to both sides, I get minus 6y is greater than 30. Divide both sides by negative 6, and we'll reverse the sign. So y has to be less than negative 5. So there's my set builder notation. It has to be less than negative 5. So it's going to be here. It has to be greater than positive 1. So it's going to be here. And my interval, negative infinity to negative 5 and 1 to infinity. So when my absolute value inequality is greater than, like in this example, you need to write 2 inequalities. I have one more set of examples here. Oh, that font's big, isn't it? So 4 minus 4x. Oh, this one's less than. So that tells me to put it into a compound inequality. Let me try this again. Scoot this over a little bit. So negative 12 is less than or equal to 4 minus 4x is equal to positive 12. So subtract 4 from all 3 sides. So negative 16 is less than or equal to negative 4x is less than or equal to 8 positive. Now I need to divide all 3 sides by negative 4. So this is going to give me positive 4. This is going to give me x, and this is going to give me negative 2. But remember, when you divide or multiply an inequality by a negative, you have to reverse the sign. So I reverse the sign, and really, to be more correct, I should put negative 2 is less than, is between, x is between negative 2 and 4. I could write interval negative 2 to 4. Anything between those two numbers, including the endpoints, will satisfy that absolute value inequality. Okay. Now this one is greater than. So that means 2 inequalities to get rid of the absolute values. So 3v minus 12 is less than or equal to negative 19. And 3v minus 12 is greater than or equal to positive, not 19. Where did I get 19? Just 9, sorry. This is negative 9, and this is positive 9. So now I solve plus 12 plus 12. So 3v equals 3, or less than or equal to 3. Now I'm not dividing by a negative, so I'm going to leave the sign alone. 1. And over here, add 12, 3v is greater than or equal to 21. So v is greater than or equal to 7. So I know that v is less than or equal to 1. So that's from minus infinity to 1, including the endpoint of 1. And also a solution would be anything from 7. V is greater than 7 to infinity. So here is my set builder notation. Here's interval notation. I didn't do a number line on these two, but you sure could. So that's how the absolute value inequalities work. If you have less than, then you're going to have a compound inequality. Absolute value less than, then compound inequality. And what do I mean by that? So if this is less than 2, then I'm going to rewrite this as x is between -2 and 2. That's a compound inequality. If my absolute value is greater than, then I have to qualities. Oh, goodness, I can't even write. What does that say? Inequalities. So x is less than -2. That's for example, and x is greater than positive. If I have an absolute value greater than some number, I have to have 2 different inequalities. If it's less than, then I can write it as one compound inequality. Okay, so hopefully that'll help you out with the absolute value inequalities. I know they're kind of confusing. Just think about distance. That might help. That's all.